All right, so here we have a question that has a lot of different components to it. So it's probably going to be best just to draw a picture of what's going on to start with. So here's a picture that shows the ions that are going to be in solution. Um, Now, I've drawn a couple of chloride ions because the magnesium to chloride ratio is 2 to 1, and then one of the nitrate, one of the nitrates, one of the silver. So what's going to happen here? Well, hopefully we recognize that this is a double replacement reaction. So we've got the silver nitrate as one reactant, combining with the magnesium chloride as the other reactant. And so the solid that's going to form here, hopefully remember that nitrates are always soluble, so they're never going to form the precipitate. So our solid here is going to be the excuse me, the silver chloride. And then the other two, the ions, the magnesium and the nitrate, are going to be spectator ions. I can draw those together here, aqueous, but we realize that they're really just going to stay dissolved in solution. Okay. Now here's one way of looking at it, but I think a better way of visualizing this one is just to look at the net ionic equation. So get rid of the spectator ions. So the ions that are actually going to react are the silver plus ions and the chloride negative ions. Right, so these are both aqueous. And then they're going to form then our precipitated silver chloride. Okay, now let's go back and take a look at the question and see what we've got up there. So we know the volume and the molarity of the magnesium chloride as well as the volume and the molarity of the silver nitrate. And then what it wants us to find is the chloride ion concentration as well as the mass of the solid form. So we want to know this, and we want to know something about this. Now, according to the reaction, the chloride's reacting with the silver. So there's a chance that all of the chloride gets used up, and there's none of it left, in which case the chloride ion concentration would be 0. So what ends up being then is a limiting reactant type problem. So what we're going to do is we're going to take those volumes and the molarities and kind of put them underneath here to see what what we have in terms of moles of each of these things, each of the reactants. So the silver, we have 100 milliliters of the silver nitrate, and the concentration of the silver nitrate is 0.005 molar. Well, for every 1 silver nitrate, I have 1 silver. So that would be the same concentration for the silver ion, 0.00500 molar. And then for the chloride, a little bit of a different situation here. Again, we have 100 milliliters of the magnesium chloride solution. However, if we look at the formula for that, right there, there's 2 chlorides for every 1 magnesium. So although the magnesium chloride is 0.01 molar, the chloride ion itself is actually going to be double that, so 0.0200 molar. Okay. All right, and now again, the best way to do this is to deal in moles. So we're going to go ahead and figure out how many moles of the silver ion we have and how many moles of chloride ion we have. So to do that, we're going to use our molarity formula. So moles equals molarity times volume, provided it's in liters. So for the silver, that's going to give me 0.000500 moles of the silver ion. And for the chloride ion, we're going to have 0.00200 moles of the chloride ion. All right, so we're going to move down here a little bit. So we can still see the equation here. Now, obviously, according to the equation, this is balanced, so it's 1, 1, making 1. If I take a look at my silver here, for every 1 mole of silver, I would need 1 mole of chloride. So if I have 0.0005 moles of silver, I'm only going to need that much of the chloride. So I could go ahead and subtract that because I can tell already that I've got extra chloride ion present. So if I subtract the 0.00500 moles of chloride that I'm going to need, that's going to leave me with 0.0015 moles of chloride left over. So we can go ahead and solve the first part of the question now, where it wants to know the concentration of the chloride ion. So the concentration of the chloride ion, so this is moles per liter, would be moles of the chloride ion divided by the liters of the solution. So we just solved for the moles of chloride ion that were left over. So that was 0.00150 moles of the chloride ion. And then the volume, so at this point we need to kind of assume that these volumes are going to be additive. So it will be 200 milliliters or 0.200 liters. And so we go ahead and do the math there, and we would get 0.0075 molar for the chloride ion. And let me just double check that real quick. So it does seem to check out. So that would be the concentration of my chloride ion. And then to figure out the mass of the precipitate, I'm going to go ahead and use my limiting reactant, which was the silver ion. So 0.00500 moles of silver ion. And I know for every 1 mole of the silver ion that's in solution, I will produce 1 mole of the silver chloride solid. And each mole of the silver chloride solid has a mass of 143.3 grams. And so that leaves me with a mass of 0.0715 grams of the silver chloride produced. All right, so a lot goes into that problem. I guess I should go back and double check my units, make sure they're all canceling out. A lot of work goes into that, but it really shows to work through this problem, you've got to understand how the particles are going to break apart in solution. You have to know the types of chemical reactions happening that you're forming to precipitate. Obviously, you have to think about the limiting reactant situation that you've got going on here, where the chloride is going to be left over, the silver is going to get used up. So a lot of different components from the year, the second semester, that factor into this, and so that's what makes it kind of a good question for us to work on to get ready for the exam.